Fire is so strange. It's not a solid, it's not a liquid, and it's not even really an object. Video games have been fooling us with fake fire for decades, but I wondered, could I simulate realistic fire by using real-world physics concepts? I know this sounds pretty cool and all, but little did I know that this would take over the next 2 weeks of my life. So ladies and gentlemen, this is how I simulated fire in Python from scratch. Alright, now, before writing a single line of code, I needed to answer one question. What in the world is fire? It's clearly more than just glowy stuff, because, well, yeah. Fire is mostly just hot gas, and hot gas behaves like, believe it or not, a fluid. But since I'm the smartest human on the planet, I decided not to take the fluid-based approach and decided on using particles. Particle systems are used everywhere in games, models, and simulations. Smoke, rain, explosions, and fire are often created by spawning a bunch of tiny objects and giving each one its own movement. I started my own simulation with a basic particle class where each particle stored 4 main things: its position, velocity, size, and lifetime. Every frame I would spawn a group of particles near the bottom of the screen and give them a random horizontal position. Then, to make it rise, I gave each particle an upward velocity. At this point, I technically had fire, but the problem was that it looked very unnatural and each particle followed the same exact path, so it looked like an orange box. To fix this, I added heavy randomness to the particles' values, which made the particles feel way more chaotic almost immediately. Visually, however, they were still just fat orange circles. I made each particle shrink in size over time to give more of that typical fire effect. I also added changing color based on how long the particles had been in the simulation, so that the newest particles near the base were brighter with more yellow and white. And finally, I added a glow effect around each particle to soften the edges and make the flame feel brighter. After all of that, the result honestly looked pretty good. Like, from a distance, you could look at it and be like, yeah, that's fire. But the longer I stared at it, the more apparent the problem became. Every single particle was completely independent. One particle had no idea where the others were, and they just couldn't pull each other around. They couldn't curl into vortices or flow together as one flame. So technically, all I had really created was a bunch of glowing circles that moved in the same direction. And don't get me wrong, this method is amazing for like stylized effects and video games, but I wanted my fire to be as realistic as possible. Real fire behaves like a continuous mass of hot gas. Like a fluid, who would have guessed? So if I truly wanted to simulate real fire, I couldn't just simulate individual objects, or maybe I could, but I don't have that brain power or the laptop power to figure that out. So I would have to simulate the air around the fire itself, and that meant replacing the entire particle system with a fluid simulation. Alright, so now that I've deleted 500 lines of code, where do I even begin? Well, instead of tracking thousands of individual particles, I split the entire screen into a grid. Every single cell in this grid would store important information about what was happening in that tiny region of space. Each cell kept track of how much smoke, or in my case density, it contained, how hot it was, and the direction of the air inside it that was moving. This approach is known as a Eulerian fluid simulation because instead of following the fluid, we're observing what happens at the fixed points in space. Of course, an empty grid isn't exactly a fire, so I gave the fluid velocity, buoyancy, and advection, and every frame I injected new density and temperature into the bottom of the simulation, essentially creating an infinite fuel source. These ideas all came from Joss Stamp's famous paper, Stable Fluids, which introduced a fast and stable way of simulating Navier-Stokes equations in real time. If you want a much deeper explanation of how all that works, I actually made an entire video dedicated to building a fluid simulation from scratch. Now, at this point, I technically had a fire, but it behaved more like a blob of smoke than an actual flame. So I started bending the simulation to look more like real fire. I added turbulence to create flickering motion, flame shaping to pull the fire into that familiar teardrop shape that we all know, and a height limit to stop the flames from stretching halfway across the screen. Now, I really want to explain how I got the fire to look like fire and not a big column of death. I realized that real flames are being pulled towards a center constantly. So every frame, I calculated how far each cell was from the center of the flame. Then I applied a tiny sideways force that pulled it back towards the center. Finally, I made the center slowly drift from side to side over time so the flame could dance naturally instead of looking perfectly symmetrical. And with just a few lines of code, my giant orange blob suddenly started looking like an actual flame. And as a finishing touch, I added particles. Yes, after deleting 500 lines of particle simulation, I brought them back as a finishing touch. Honestly, I'm pretty happy with how it looks. By applying fluid concepts in a unique way, we were able to simulate fire with just a few adjustments. Be sure to check out my fluid simulation video for more in-depth explanation about stable fluids and Eulerian fluid simulations. Thank you guys so much for watching. Be sure to like, subscribe, hit that notification bell, and I'll see you guys later. But until then, peace.